let's look at if net and impulse. So the formula is just if net multiplied by time is equal to the change in momentum or the impulse, right? So if we try to solve for if net, we will have the change in momentum over the change in time. So if net is the rate of change of momentum. This is an alternative way of stating Newton's second law. If net is equal to ma. Now let's look at impulse from a graph, right? So as time goes to the right like that, the if net increases, right, until a certain point where it now just comes down like that, right? Now let's see, right? So it just means as we increase time, right, eventually we're going to make if net smaller, right? Remember, we have this if net is equal to change in P over the change in time. So as we increase the time, what are we doing to if net? We're decreasing it because they are inversely proportional. Now this is why, let's look at impulse and safety systems. This is why we use airbags in our cars. Whenever an accident happens, the airbag comes, right? Why does the airbag come? It increases the contact time, therefore the net force is going to be less, and then the chances of you getting hurt are less. And also the crumple zone in front of a car, right? It increases the contact time and it reduces the chance of injury. Whenever you jump, you should also bend your knees, which increases your contact time and making you less prone to injury. Now it's your chance to pause and try the following question. Okay, now that you've paused the video and attempted the question, let's see if you're on the right track. A, they said determine the velocity of the SUV immediately after the collision. Now remember this, the cars did not stick together, right? So this means we can use the conservation of momentum, but now we can just say M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. The U just means initial velocity. So instead of writing VI, you can instead use U. Then let's substitute. So we have 1084 times the velocity initial, which is 33, plus the mass of the SUV, which is 3437, multiplied by its velocity, but it's moving in the opposite direction, so it'll be negative 28. Then we have the mass of the car still being 1084, then its velocity is 5, but waste, so that'll be minus 5 there. Then plus the mass of the SUV, 3437, and we want to find its velocity. So now let's quickly solve for V2 there. Let me just put that 2 to show that it's the second object. Now let's quickly check what this guy gives us there. On our calculators, we can quickly say 1084 multiplied by 33, and that gives us 35772. So 35772. Then this will be minus, let's check that on our calculator as well, 3437 times 28, and that is just 96236. And this is equal to, let's check that on our calculator, is 1084 times 5, and that is minus 5420 plus 3437 V2. And let's solve that there. Now we know that can just say 3, 5, 772 minus 96236 plus 5420, which just gives us minus 55044 is equal to, remember there's a negative there, 3437 V2. Then let's divide both sides by 3437. Then V is going to be equal to 16 meters per second. In which direction? To the right. Why? Because the answer that we found there was negative. Now let's go to the next one. Now they're saying the contact time of the collision was 0.2 seconds. Determine the net force experienced by the car. Right. Remember, if net is equal to the change in momentum over the change in time, then the change in momentum, we can say it's the final momentum 5420 minus the initial momentum, which is 35772. This will be over the change in time, which is 0.2 seconds. And let's check, that is just negative 41192 over 0.2. Then let's check on our calculators. And that gives us negative 205,960 newtons. Right, and this is a very big force because it bumped into a car with a very big momentum. So it bumped into this one and it even changed direction, so you expect this to be quite big. Now let's carry on. Then they're saying determine whether the collision is elastic or inelastic by use of an equation. So first let's find the kinetic energy before the collision. So we know, I'll just say EK before is equal to half m1 u1 squared plus half m2 u2 squared. So it's quite easy. Now we just substitute 1 over 2, the mass of the car 1084, then the velocity was 33, we need to square that, plus 1 over 2, the mass is 3437, and then the velocity is 28 but in the opposite direction, but it wouldn't matter that much because we are going to end up squaring it. Now we just rely on our calculator to find what that is. Let's quickly do that. And that gives us 1937,542. That is the kinetic energy before. Now we need to calculate the kinetic energy after. Let's quickly do that. So for after, let me just draw a line there so that we don't end up mixing the two. Then we'll use the same formula, but we'll use V. So V, remember, it stands for final velocity. So I can just say this is equal to half 1084. The final velocity of the car was 5, but in the opposite direction, but that doesn't matter because we're going to end up squaring it, plus a half 3437, and then the velocity of the SUV was minus 16, but it doesn't matter because we're going to square it. Now let's check if we're going to get the same answer as above. So 0.5 times 1084 times 25, and then plus 453,486,0, and therefore the collision was inelastic. Because the kinetic energy before is not equal to the kinetic energy after. Now let's carry on. Right. D says the fireman at the scene of the collision tells you the vehicles are crumpled up because modern vehicles are made cheaply. Is he right? Explain. No, he isn't right, because modern cars are fitted with crumple zones. Why? So that they can decrease the contact time. And remember, we know that F net is equal to the change in momentum over the change in time. Now, if they increase the contact time when they crumple, this means the forces will be less. So he isn't right, because these cars are made to crumple so that the forces on the people is less and to reduce the chance of injury. Now, why should people wear seat belts? Refer to a law of physics in your answer. So remember, during a car collision, there is no unbalanced force on the person. So according to Newton's first law, the person will continue to move at the same speed. The main purpose of a seatbelt is to bring an unbalanced force to the person by stopping the person from moving out of the car. I hope you enjoyed this workshop on momentum.